Next, we want to talk about infinite limits at infinity. And it says no polynomial function has a finite limit at infinity. Rational functions whose numerator has a higher leading coefficient than the denominator don't have a finite limit at infinity either. That's the big on top. So the end behavior of these functions can be made with this notation. We can either say that it approaches infinity or negative infinity. So if we look at letter A here, it says find the limit of x cubed as x approaches infinity. So we just think as x increases without bound, what happens to our function? Well, x cubed also increases without bound. And so when this is the case, we know that this limit we can write with the notation equals infinity. For letter B, here, as x decreases without bound, okay, and it decreases because we're going to negative infinity, what happens to x cubed? Well, we know when we cube a negative number, it stays negative, and so x cubed also decreases without bound. And so this one we can say equals negative infinity. Now, this was a polynomial function, so we knew it either had to be infinity or negative infinity. And notice as we draw the graph here of x cubed that we can see visually this is the case. Now in our next example, here we have a rational function where the exponent is bigger on top. And so when it's big on top, the limit doesn't exist, but we can still use our notation of infinity or negative infinity. Now one way that you can solve this is by actually performing the long division here. So we're going to set up our long division, 2x squared minus 4x. We're going to divide it by x plus 1. And we just say x goes into 2x squared how many times? Well, 2x times. And then we multiply 2x by x plus 1. So it gives me 2x squared plus 2x. And then we have to subtract this. So I go ahead and change the signs of both of these. And I like to always circle when I change my signs. Now this drops down to 0, which is what we want. And negative 4x minus 2x is negative 6x. And now I say x goes into negative 6x how many times? Well, negative 6. And so now I multiply negative 6 times x plus 1. And so I get negative 6x minus 6. And then because I'm subtracting, I'm going to change both of these signs. And again, I circle those there. So we get 0 and then plus 6. Now x no longer goes into 6, so we just write this as a fraction plus 6 over x plus 1. Now, what we did here is we know that this function and this function are the same thing. And so we're going to rewrite our limit now using our new function, the limit as x approaches infinity of 2x minus 6 plus 6 over x plus 1. Okay, so as we look at this, this is going to be 0 here. This would be negative 6. And this part right here, well, it's just our polynomial function, 2x. And if x keeps increasing, this function 2x is also going to keep increasing, so we get infinity. And so we do write infinity for this one right here. So we can write equals infinity. Now for example 2, we've already done the long division, so we're just really going to write our limit with our new function. So x is approaching negative infinity of 2x minus 6 plus 6 over x plus 1. And again, here this is going to give us 0. This is going to give us negative 6. And this one, as x decreases without bound, 2x will also decrease without bound. So here we get negative infinity. So all in all, we get our limit is negative infinity. So what this statement is saying, and by doing the long division, as x approaches plus or minus infinity, the function 2x squared minus 4x over x plus 1 behaves like the function 2x minus 6. So notice this part really didn't matter. So this function is now behaving like this function, and this actually becomes our slant asymptote right here of y equals 2x minus 6. So if we were going to draw a graph, we could draw the line 2x minus 6. So we'll just have this here at negative 6. This will be at 3, 0. And this would actually become an asymptote. And this function, if we were to graph it, actually looks like this. Not very exact with our max and mins, but the end behavior, this would start following this line right here and right here. So that's how you deal with infinite limits at infinity and finding slant asymptotes.